Hi everyone, it's Miss Landis here, and today as part of our contingency plan day 7, we are working on topic 16, lesson 2, which is classify triangles. Our outline for the lesson is to complete the solve and share, complete the convince me, complete the look back, and then work on numbers 1 through 15 and number 20 on page 829 to 830. First, we will read the lesson title, Classify Triangles, and our I can statement. I can reason about line segments and angles to classify triangles. Our solve and share is to sort the triangles shown below into 2 or more groups. Explain how you sorted them. So you have a few triangles here listed from A onto G, and you have to sort the triangles into different groups. So if you would like, you can pause the video here and try to do that independently, and then I will go over one way that I decided to sort the triangles. All right, so when I decided to sort the triangles, I first looked at their sides and their angles. All triangles have 3 sides, so looking at their sides, some of their lengths might be different or some of their lengths may be the same. Looking at their angles, every triangle has 3 angles. The angles that we look at are explained as either right angles, obtuse angles, or acute angles. Now, we haven't learned about angles yet in class, so that's going to be another challenge for you in this lesson, is to learn about the different types of angles, and I'll explain that when I explain the lesson. So first, I sorted my triangles by their sides, and I said, okay, well, I see 2 triangles that look like their sides are all the same length. So I decided to make a category, 3 sides with the same length. And I decided that triangle B and triangle G, they looked like their sides, all 3 were the same length. So in that category, I put B and C. And when I used those triangles, I just decided, put a check mark on them. So now I have 5 triangles left. Knowing what I know about angles, I know a right angle has a square corner. And I kind of flipped my page around to look to see if any other triangles had a square corner. And I noticed E looked like it had a square corner. Triangle D looked like it had a square corner. And triangle A. So I decided to make my second category have to do with the angles. So triangles with right angles. And in that category, I'm putting A, D, C, and E. So I used A, D, C, and E. So that leaves me just with F. So then I was thinking, how can I classify triangle F by its sides or angles? And one thing I noticed about F is these 2 sides here look to be the same length, but this longer side on the bottom is definitely a different length than the other 2. So I made my third category 2 sides with the same length. And in that category, I'm only putting triangle F. Now, there are tons of other ways that you could have sorted these triangles. You don't have to do it this way. You could have also classified these triangles into different types of groups, but that's just one way that I solved it. Now let's check out our look back. The look back says, what is true about all 7 triangles you sorted? In order to answer this question, think about the properties of a triangle. When you're looking at a shape, how do you know that it's a triangle? What can you say is true about all 7 of these? You could take a moment to pause the video and try it independently, and then I will write an answer. All right, so thinking about the properties of triangles, we're talking about their sides and angles today. So I know that in order for me to say a shape is a triangle, it needs to have 3 sides. So what is true about all 7 triangles? All 7 triangles have 3 sides. Now, how many angles do they have? Every triangle also has 3 angles. The angle is the point where 2 lines meet. So in looking at just G here, it has 3 angles. So all triangles have 3 sides and 3 angles. And that's how we can answer our look back. So let's turn the page and read through our lesson. And I'm going to make some notes on this page so you can make these notes too, and it will help you when you go to do your independent practice. Our essential question is, how can you classify triangles? The word classify is an important word here that we might be confused about. To classify means to name or sort something. So we're going to be naming these triangles and sorting them into different groups. The first way that we can classify triangles is by their sides. So I'm going to just put a box around sides here. The first type of triangle is an equilateral triangle. And an equilateral triangle has 3 sides that are the same length. And you'll be able to see it a lot of times because they'll draw these lines here to show equivalence. An isosceles triangle has at least 2 sides that are the same length. So 2 sides will be the same length and the one side will be different. And again, you'll see the equivalence in the sides where the lines are. A scalene triangle has no sides the same length. All 3 of its sides are different lengths. We can also classify triangles by their angle measures. So put a box around angle. A right triangle has 1 right angle. Now, most of the time you will see the little square in the corner to show that there's a right angle there. An acute triangle has 3 acute angles. All of its angles measure less than 90 degrees. Now, when we talk about angles, we haven't discussed it too much in class. These are the 3 types of angles: right, acute, and obtuse. Acute angles are small, and when you see them in the triangle, those angles are all going to be less than 90 degrees. So that's a note that we can make down here. And maybe we'll just title this angle measures. An obtuse triangle has 1 obtuse angle. Key word here is 1. a triangle can only have one obtuse angle, and we can talk about why when we get to the convince me. Here would be the obtuse angle. And I'm drawing these markings in the corners of where the angles are because it kind of helps me see how wide that angle is. And I can tell that this angle is open more than the right angle. So an obtuse triangle has one obtuse angle. One angle has a measure greater than a right angle. So obtuse is greater than 90 degrees. And in class, when we get to angles, when we talk about the difference between acute and obtuse, there's a word that's in acute that kind of helps me remember it as a trick. So if you think about the word cute, the acute angle is small, it's little, we call it an acute angle. The obtuse, we kind of stretch that word out and say an angle is obtuse. It's bigger than a right angle. It's bigger than 90 degrees. So we have acute and obtuse. So important thing to remember here, we are going to be classifying angles by their sides, or I'm sorry, classifying triangles by their sides and their angles today. Let's slide down to the convince me. Can a triangle have more than one obtuse angle? We can solve this one together because I said that I would explain this. By definition, an obtuse triangle has one obtuse angle. If you were to try to draw a triangle that has more than one obtuse angle, well, first we need to make an angle that's bigger than 90 degrees. So it needs to be open pretty wide. So see how wide I had my angle open? Well, if I were to draw another really wide angle, maybe starting it here, I already have a three sides in my shape, and I still need a line to close it. Now that is not a triangle because it doesn't have three sides, it has four. It's actually a quadrilateral. So can a triangle have more than one obtuse angle? A triangle cannot have more than one obtuse angle. And it really gets into the measurements of a triangle. All triangles, their angle measurements need to measure 180 degrees. So since an obtuse angle is so big, it measures more than 90. Two obtuse angles would already measure 180 degrees. So we can't have another angle in that shape and still have three sides and three angles. So let's get into our guided practice. Now for today, you are completing 1 through 15 on this page, and then number 20 on the back. If you want, you can take a moment to pause the video and try numbers 1 through 6 independently before I go over them in just a second. All right, so starting with number 1. Sally classified a triangle as an obtuse acute triangle. Is this a possible classification? Explain. Now, something that I'm going to do is just detach this page because I want to look at them side by side, because this whole section right here is going to help you complete everything right here. So as I'm looking at what an acute triangle and an obtuse triangle is, an acute triangle has 3 acute angles. So in order for me to say a triangle is acute, it has to have 3 acute angles. So if she is saying that a triangle has obtuse and acute angles, we would just call it obtuse, because in order for us to name a triangle as obtuse, an obtuse triangle has one obtuse angle. If it has one obtuse angle, it is already just called an obtuse triangle. So let's find a way to say Sally is not correct. I'm going to say Sally is not correct because if a triangle has one obtuse angle, it is, let's use that good word, classified, a good vocabulary word. It is classified as obtuse. And I'll zoom in a little bit here so you can see that better. There we go. Number 2, can a triangle have more than one right angle? If so, draw an example. And this would be a good time to try to draw one and see what happens. It's kind of like guessing and checking. So you could use this space, or you could use a piece of scrap paper and try to draw it. So I'm going to use the space and see if I can draw one. Well, in order for me to have a right angle, I need to make a square corner. Well, if I made another square corner, I already have 3 sides. So the only way that I would be able to close the shape would be to end up making it a square or a rectangle. And that is not a triangle. It has more than 3 sides. So a triangle cannot have more than one right angle. All right, let's read the directions for 3 through 6. Classify each triangle by its sides and then by its angles. So we need sides and angles. So side by side with my work paper, I'm going to have kind of my cheat sheet here that will help me. So for number 3, let's look at its sides first. And in looking at my How Can You Classify Triangles paper, I do see a triangle that has 2 little marks showing that it has 2 equal sides, and I know that that is an isosceles triangle. Make sure you spell it correctly. So I classified by the sides. Now I'm going to classify by the angles. So look at its angles. When you see a triangle that's really skinny like this, you can tell that none of the angles are open very wide. If you don't see any very wide open angles, then automatically it's going to be acute, because an acute triangle has 3 angles that are less than 90 degrees. So you'll see really small openings here where the lines meet. So that is an acute triangle. Now for 3 through 6, you should have 2 different words to classify by the sides and to classify by the angles. Number 4 matches one of the pictures over here an equilateral triangle. We can see the 3 lines showing that those 3 sides are equal. So number 4, classifying it by its sides, we can call it equilateral. And classifying it by its angles, it is also an acute angle because all 3 of those angles measure less than 90 degrees. They're all very small openings in the corners of that triangle. Number 5, let's classify it first by its sides. Something that you could do here that might help you see it a little bit better is to just kind of like trace over the sides. And I can see those 2 sides are definitely not the same length. And that 3rd side doesn't look to be the same length either. So we can call this triangle scalene. All 3 of its sides are different lengths. And I kind of traced over my square corner here, but that's going to help you. If you see that little square in the corner, you know automatically it has a right angle. So it's a right triangle. For number 6, classifying it by its sides, once again, I don't see any of those lines showing equal sides. All of these sides are different lengths. So this triangle is scalene. I do not see a square in the corner anywhere, so I know it's either acute or obtuse. So I'm looking for an angle that's open really wide. And this angle right here is open more than 90 degrees. It is an obtuse angle. So we're going to call this an obtuse triangle. I know this might be a lot for today because we haven't really talked about angles too much this year, but as long as you are looking at this paper to help you, then you should feel a little bit more comfortable in completing the independent practice when you're looking at this paper. So you can go ahead and complete number 7 through 15 and number 20 on the back. We miss you guys so much, and I hope that you are being safe and healthy at home, and look for tomorrow's video to help you with 16-3. See you guys later.